Okay, so this is our review for Unit 8. Let's get going here. So we have Pizza charges $10 per pizza plus 2 for each topping. Domino's looks at 14 for each pizza plus $1 per topping. You're going to choose the two equations that represent these different plans. So for Pizza Hut, we're looking at 10 and then 2 for a slope. So for Pizza Hut, we have 10 and 2 for a slope. So this one's wrong. This one's wrong. This one's okay, so we're at either choice A or D right now. For Domino's, it said 14 per pizza and then $1 for each topping. So if we're looking here, this one won't work, so our choice is A. All right. Now, we want 2 toppings. Where should we go to order pizza? So if we're looking at the number 2 on toppings here, again, we could either use the graph or plug in. So if I'm looking at the graph, let's see, my starting value for Pizza Hut is 10, the Domino's is 14, so this red line here is my Pizza Hut. Blue line is Domino's. So if we want it 2, it looks like Pizza Hut's going to be cheaper. So Pizza Hut, it's lower there. 5 or more toppings. So if I wanted 5 or more, now Domino's is cheaper because it's lower down there for the total cost. Okay, looking at which ones are which. So if we look at our shaded region here, we're looking at the point 30. So 30 is here. So our choice for that one, yes, it is in the shaded region. The point 42, so 412. This one's in the shaded region. We can be a little more specific. Yes, it is in the solid line bordering the shaded region. 2, -4, 2, -4. Now, remember, our dashed line is not a solution, so no, it is on the solid line, not no. So we want no, it's not, and then no, it is on the dashed line. Lastly, 1, 4, so 1, 4. This one's just not in the shaded region at all, so no, it is not in the shaded region. All right. All right, moving on. Number 8. Choosing the correct solution, we can see this is meant to be 2 lines. So when 2 lines are completely overlapping, that means we have infinitely many solutions. If we had 2 parallel lines, it'd be no solution. And the other 2 choices, again, we've discussed in this unit. Here, we're looking to solve the system and identify the y coordinate of the solution, so the y value that makes it work. Here we have 2 equations that are set equal. So we can substitute directly and set them equal and solve. So if I subtract 4 over, that'll cancel out. I'd get 5x is equal to -7x. If I add 7x to both sides, I'd get 12x is equal to 0. And dividing by 12, I'd end up with 0. So if I plug in, say, to my top equation, I'd have y is equal to 5 times 0 plus 4. And I'd end up with y is equal to 4. So my answer would just be 4. All right, it says we could solve by any method. So for 10, we see that we already have a y by itself, so we can go ahead and substitute directly in. Distributing. Combining. Adding that 8 over. And dividing by 7. And then lastly, to get my y value I'm going to plug in, I'm going to go ahead and use this bottom one here because y is already by itself. We could use the top one as well. So half of 2 is 1, minus 4, minus 4. So I'd end up with y is equal to -3. So my solution would be B. Going on to 11 here, we see nothing's y by itself, so let's go ahead and use elimination here. So I'm going to cancel my x's. So to get the same value, one positive, one negative, I would need to multiply everything on the top here by 2. So that would give me -4x minus 2y is equal to 24. So if I go ahead and I'm done with this one now, so I'm going to add down. 4x minus 4x gives me a 0x. 2y plus negative 2y gives me plus 0y. And then I end up with 33 over here. So if I think about it, 0 times anything is 0. 0 times anything is 0. And 0 plus 0 gives me 0. So I have 0 is equal to negative 33. As we know, that's not correct. So we'd end up with no solution. Had I arrived at something like 5 is equal to 5, or x is equal to x, then I would have infinitely many. Okay, we have Cynthia is currently working 2 jobs. She makes $8.25 per hour teaching dance classes and $5 per hour babysitting. She wants to earn at least 70 and can't work any more than 15 hours. So it gives us our variables. So if we think about this, we can't work any more than 15 hours. So I know that if I add my 2 hours together, it cannot be, any greater than 15. So if I add them together, it's going to be less than or equal to 15. That's what the words no more than mean. If I think about how much I'm making, let's see, I get $8.25 for every hour teaching, and then I get $5 per hour for babysitting. So now if we think about that, we've said we want to make at least 70 per week, so we want greater than or equal to 70. So if we're looking at which one of these makes sense, we want choice C. So x plus y is less than or equal to 15, and then add them together greater than or equal to 70. Now we're looking to choose the correct graph. So if we're thinking about this one here, when we graph these two, again, using either a graphing utility or if we go ahead and just kind of sketch them out by hand, we're looking at, okay, so C and B should immediately make absolutely no sense to you. And then if we're looking here, so those intercepts for that x plus y is less than or equal to 15, or less than equal to 15 equation, we're looking here at choice B. So we would shade below the red, saying that we need no more than 15 hours. We want it to make at least 70, so the blue line will be shaded above. So this is that region here where we're shaded on both. So our choice is choice D. Looking down here, we're going to graph and name our solution. So for our top one, we got to get our y by itself. So I'd subtract x from each side. Divide everything by negative 2. So for that line, I could look right here and see that both of these are the exact same equation. So I just have to graph it once. And again, they're going to kind of overlap each other, so we talked about drawing the double arrows there. Now again, I have two equations with the exact same line, so I have infinite solutions, or infinitely many solutions. Here I have y is equal to negative 3, so that's a horizontal line here. And then if I solve this one for y, I'd have negative 1x minus 2. So our solution for that one would be this point here where they intersect, and that's at 1, negative 3. Alright. Looking here at our system, so x is less than 4, so x in a 4 gives me this nice dashed line here. And then for this one, if I solve for y, I'd have y is greater than or equal to negative 2x plus 3. I'm just going to make that blue. So my blue one. So I'm at positive 3, down 2 over 1. I'm just going to go ahead and throw a few more in here just for accuracy. And that's a solid line. So it looks like I want to the left of x. So I'm going to the left of x, so I'm somewhere over here. Right? And then I want above my blue line. So the above the blue line is over here, which again, My apologies for my shading. We know it's not the best. Our solution area is going to be in between these lines here. So we're less than the red and greater than the blue. Or again, we use that test point method. That would work as well. All right. So we've got to solve this top one first. Let's go ahead and do that. So I'd subtract 5x from both sides. Divide everything by 2. Let's go ahead and graph that one first here. So I'm at positive 2, down 5, right 2. We wanted a dashed line. Now let's go with some blue again. So this is my blue here. So I'm at negative 2, and then I go down 1 over 2. It's a solid line. Okay, so for our shading, for this line, we're above the black line, so I'm looking at anything up over here above. For the blue line, we are looking at above as well, so that means everything over here. And we see our area of overlap would be up here. So this is our green good to go area. All right, and again, or you could use that 4-point method we talked about earlier. Okay. Question 18. We have during the summer you decided a lawn care service for people who work all day. You purchased a lawnmower that costs $149. You also use $3.50 worth of fertilizer in the garden at each house. You are going to charge people $20 to tend their yard. How many yards for you to break even? So if I think about this, my cost equation, right? So my cost equation here says I spend $149, and then every time I actually go and work on one of these yards, it's costing me $3.50. So I'm going to call that 350x because it's for each yard. The other equation says that I'm going to charge people $20 for each yard. So we want to set these equal to one another. It doesn't matter which one you write first, right? Because we're just substituting. So I'd subtract that 3.50 from each side, giving me 16.50x is equal to 149. So I have 149. If we go ahead and divide, sorry, I had to sneeze. So we're looking like 9.03. Now, as we've talked about before, is it possible that I could mow 9.03 yards? Probably not, right? So I couldn't tend to 9.03 yards. So we're going to need to round that up. So I'm going to need 10 yards done, because at 9 yards, I'd still be a little bit losing money. So I want to get 10 done to start making money. Then here, if we tend 13, how much will my total profits be? So I need to figure out my income minus my costs, and that's my total profit. So this here is my cost equation. This is my income equation. So for the first one, I just have 20 times 13. So that's going to give me $260. For my costs, I'd have 149 plus 350 times 13. So I have 194.5. And again, if we subtract these two amounts, that gives us my actual profit. So I have 260 minus 194.5. I end up with a profit of $65.50. So that's how much I'd actually make. All right, the last two problems here for our Unit 8 review. We have Jason makes $9 per hour leading zipline tours and $15 for teaching swim lessons. One weekend, he worked a total of 21 hours and made $237. How many hours did he give swim lessons? All right, so let's think about what we have here. So if we think about ziplining, that gives me 9x and then 15 for swim lessons, so 15y. All right, so that tells me how much I make. And then, let's see, in 1 weekend he worked a total of 21 hours and made 237. So if I have x plus y is equal to 21, and it says I made this much, right? So I made 237. And we need to figure out how much did I make those swim lessons for, or how many hours, I should say. So let's go ahead here. I'm going to write this a tad bit neater, just to line up my variables. Okay, so I'm going to use elimination because that's one of my favorites. You could solve for y and substitute, or do whatever you wish. So to cancel this, I'm going to multiply this whole bottom equation here by -9, so I can cancel my x's. The reason why I'm using that strategy is because all the questions asking me is about swim lessons, and we called swim lessons our y. So you could solve the whole thing, but since I know I just need y, I'm just going to solve for that. So when I multiply this out, I'll get -9x minus 9y is equal to, let's make sure we get this one right, 21 times -9, -189. So this one's donezo, right? Now I'm going to go ahead and work with my other two. So this one and this one. So when I add my x's, they cancel out. 9 minus 9 is 0. And then 15 minus -9 gives me positive 6y. Then 237 minus 189 is 48. And again, there's a variety of ways we can get here. But I'm just kind of showing you guys the fastest ways. So our answer here, we have 8 hours of swim lessons. Okay, Cheyenne has 52 coins, all nickels and dimes in her piggy bank. It's weird, but it's nonetheless possible. The value of the coins is 370. How many nickels? So I'm going to call nickels my x and dimes my y. So it says I have 52. So if I add them together, I get 52. Now a nickel is worth 0.05. So I know that 0.05x, and a dime is worth 10. So 0.1y equals 3.70. Now for this one, again, I just prefer using elimination. If you get great at it, it's fast, it's easy, and you can customize it to solve what you want. So we want to know how many nickels we have. Nickels is x. So to solve for that, I'm going to cancel out my y's. So what I'm going to do to cancel these is I'm going to go ahead and multiply this top one by -0.1. So I'm going to rewrite this down here. So I have -0.1x minus 0.1y is equal to, well, let's see, if we had -0.1, so -0.1 times 52, that gives us -0.52. Or -5.2, sorry. So we're done with that one. I'm going to go ahead and add my blue and red together. So when I add these, I end up with -0.05x. My y's cancel. And then if I do 3.7 minus 5.2, we end up with -1.5. Dividing both sides by that I should say -0.05 here. So we know a negative divided by negative is a positive, so let's just do 1.5, 0.05. We'll end up with 30. So x, or my nickels, that means I have 30 of them. All right, kept it under 20 minutes, not too bad. That is our Unit 8 review. Again, make sure we've asked all our questions, we've done our review, we're prepped and ready to ace this exam.